marveled at the intricate workings of a tiny insect. These seemingly disparate wonders, from the cosmic to the microscopic, are all governed by the laws of mathematics. And one of the most powerful tools in this mathematical toolbox is integration. At its heart, integration is about bringing together tiny pieces to understand the whole. Imagine trying to measure the coastline of a country. It's not a straight line, is it? It twists and turns with countless bays and inlets. Integration allows us to add up all those tiny segments, those infinitesimal curves, to calculate the total length of the coastline. From predicting the trajectory of a rocket to analyzing the spread of a disease, integration plays a vital role. So fasten your seatbelts and get ready for an exciting ride through the world of integration. Let's begin our exploration with physics, the science that seeks to understand the fundamental laws governing the universe. From the motion of planets to the behavior of subatomic particles, integration plays a crucial role in unraveling the mysteries of the physical world. One of the most fundamental applications of integration in physics is calculating the distance traveled by an object with varying velocity. Imagine a car accelerating from rest. Its velocity is constantly changing. Integration allows us to add up the infinitesimal distances traveled over infinitesimal time intervals to determine the total distance covered. For instance, to calculate the work done by a variable force, like the force exerted by a spring as it stretches, we use integration. Whether we're studying the motion of galaxies or the interactions of subatomic particles, integration provides the mathematical framework for unraveling the secrets of the physical world. From towering skyscrapers to tiny microchips, engineering is all about designing and building structures and systems that improve our lives. And behind these marvels of engineering lies the power of integration. Consider the design of a bridge. Engineers need to ensure that the bridge can withstand the weight of traffic, the force of wind, and other stresses. Integration helps calculate the stresses and strains on different parts of the bridge, allowing engineers to optimize its design and ensure its stability. Determining the lift generated by an aircraft's wings, which counteracts gravity and keeps the plane aloft, involves complex calculations using integration. From the shape of the wing to the materials used, every aspect of aircraft design relies on the principles of integration. Whether it's building bridges, designing aircraft, or developing new technologies, integration provides the mathematical foundation for pushing the boundaries of engineering and creating a better tomorrow. Economics, the study of how people make decisions in the face of scarcity, might seem like an unlikely place to find integration. But beneath the surface of economic theories and models lies the powerful tool of calculus. One of the fundamental concepts in economics is the relationship between supply and demand. The supply curve represents the quantity of a good or service that producers are willing to sell at different prices, while the demand curve shows the quantity consumers are willing to buy. Integration comes into play when economists want to calculate the total revenue generated in a market. The area under the demand curve, which represents the total willingness to pay for a good or service, can be calculated using integration. By understanding these concepts, economists can gain insights into market efficiency and the impact of government policies. Section 5: Integration in Medicine, Imaging the Human Body. Medicine, the science of diagnosing, treating, and preventing disease, relies heavily on technology to peer inside the human body and understand its intricate workings. And behind many of these medical imaging techniques lies the power of integration. One of the most well-known medical imaging techniques is the CT scan, which stands for computed tomography. CT scans use X-rays to create detailed images of the inside of the body. During a CT scan, X-rays are passed through the body from different angles. The amount of X-ray radiation absorbed by different tissues varies, allowing doctors to distinguish between bones, organs, and other structures. Integration is used to reconstruct these two-dimensional X-ray images into a three-dimensional representation of the body, providing doctors with a detailed view of the patient's internal anatomy. Another medical imaging technique that relies heavily on integration is magnetic resonance imaging, or MRI. From diagnosing tumors to assessing joint injuries, MRI has revolutionized medical imaging, and integration is at the heart of this technological marvel. Section 6: Environmental Science Protecting Our Planet. As we face growing environmental challenges from climate change to pollution, understanding the complex interactions within our planet's ecosystems is more critical than ever. And integration plays a vital role in this endeavor, providing tools to model environmental processes and predict future trends. One area where integration proves invaluable is in modeling animal population growth. Factors like birth rate, death rate, immigration, and emigration all influence how populations change over time. Integration allows environmental scientists to develop mathematical models that incorporate these factors and predict future population trends. Integration is also crucial in tracking the spread of pollution. Whether it's air pollution from factories or water contamination from agricultural runoff, understanding how pollutants disperse through the environment is essential for mitigating their harmful effects. Section 7: Statistics, Unveiling Patterns in Data. In today's data-driven world, statistics plays a crucial role in extracting meaningful insights from vast amounts of information. From predicting customer behavior to conducting scientific research, statistics helps us make sense of the world around us. And at the heart of many statistical methods lies the power of integration. One of the fundamental concepts in statistics is the probability distribution, which describes the likelihood of different outcomes for a random variable. The area under a probability density function, which represents the probability of the variable falling within a certain range, is calculated using integration. Whether we're analyzing survey data, conducting clinical trials, or studying social trends, integration provides the mathematical foundation for making sense of data and drawing meaningful conclusions. Section 8: Conclusion, Integration, a Universal Language. As we've journeyed through various fields, from physics and engineering to economics and medicine, one thing has become abundantly clear. Integration is not just an abstract mathematical concept confined to textbooks. It's a powerful tool that permeates our understanding of the world and our ability to solve real-world problems. Just as a symphony orchestra combines individual instruments to create a harmonious masterpiece, integration brings together infinitesimal pieces to reveal the beauty and complexity of the whole. So the next time you encounter a seemingly complex problem, remember the power of integration. And as we continue to explore the frontiers of knowledge, integration will undoubtedly remain an indispensable tool in our quest to unlock the secrets of the universe and build a brighter future.